So in next problem, this is on the basis of composite wall. The wall of room consists of parallel layers in contact with the cement, brick and wood of the thickness 20 mm, 300 mm, 10 mm respectively. Find the quantity of heat that passes through the 2 meter square of wall per minute. If, see here, per minute is there, if the temperature on the either side of the wall is 5 degrees Celsius and 30 degrees Celsius, and they have given the thermal conductivity value for the different value, different material. For cement it is 0.294 watt per meter Kelvin, and for brick 0.252, and for wood 0.168. So here this is on the basis of thermal conductivity of thermal heat transfer through the composite wall. They have given the value thermal conductivity of the different material. So here, so which material they have considered? They have considered three material. First one is cement. Second is the brick. Third is the wood. So of thickness, you know the composite wall concept, and these are having different thermal conductivity K1, K2. I will write as a K3. So this is T1, this is T2, this is T3, and this is T4. T1, T2, T3. The heat will passes through this walls. So now what they have given in given data? In given data, what they have given? Thickness they have given. Thickness of x1 is equals to 20 millimeter. 20 millimeter in the sense 0.02. X2 they have given that 300 millimeter is equals to 0.3 meter. Then x3 is equals to how much they have given? 10 millimeter. 10 millimeter in the sense 0.01 meter. Next, what they have given? They have given the area of the wall 2 meter square. Area of the wall 2 meter square, and they have given that 2 meter square per minute. Per minute means t they have given that 1 minute per 1 minute under 60 seconds. 60 seconds. Is it not? So next thing is K1 is equals to 0.294, K2 is equals to 0.252, K3 is equals to 0.168 watt per meter Kelvin. It's units watt per meter Kelvin. Next thing they have given that inside temperature is 5 degrees Celsius, outside temperature is T. Which one is outside temperature? This is T1 and this is T4. T4 is equals to 30 degree Celsius. For composite wall, what is the expression? Q is equals to A into T1 minus T4 into small t divided by, what is the expression? X1 divided by K1 plus X2 divided by K2 plus X3 divided by K3. So that A is nothing but 2 into T1 minus T4. Which one is greater? Which one is greater? We need to write this one first. T4 minus T1 minus T4. Which one is greater? Here T1 is greater and T4 is 278. sorry, here what they have given, outside temperature is 5, T4 is they have given that 5, and T1 is equals to 30 degree. So that 30 minus 5 divide in T. T is nothing but for 1 minute, it is 60 seconds. So here x1 is nothing but 0.02 divided by k1. K1 is 0.294 plus x2 is nothing but 0.3 divided by k2 is nothing 0.29252 plus x3 0.01 divided by 0.168. So after solving this one, all the Q value will becomes 2276.13 joules. If you want to convert it into kilojoules, what you need to do? 2.27 kilojoules. So this is the simple problem which I am solving. They will ask directly, these kind of problems will comes in your examination. So another problem, last problem, which is based on the thick cylinder concept. So thick cylinder concept, we have this formula that Q is equals to 2 pi Lk into T1 minus T2 divided by 2 pi Lk T2 divided by 2.3 log of R2 divided by R1 into T. So here also same, they will give the direct values. So thick cylinder means we need to consider the pipe, the metal pipe having the external diameter of 150 millimeter carries the fluid at 200 degrees Celsius. The pipe is covered by the layer. Just read this sentence. The pipe is covered by the layer of 25 millimeter thick of insulating material whose conductivity is 0.21 watt per meter Kelvin. If the outer surface is at 100 degrees Celsius, find the heat loss per meter length per minute. So he just read the sentence, metal pipe is there, one metal pipe is there, is it not? Of external diameter 150 millimeter, external diameter is the diameter is 150 millimeter, carries a fluid at 20 degrees inside. Through this inside of pipe, water is coming or fluid is coming at the 200 degree Celsius. The pipe is covered by the layer of 25 mm thick. Means in next sentence what they have given, this pipe is covered by 25 mm layer. Means radius is 75. This is 75 plus, so R1 is 75, R2 is 75 plus 25. So R1 is equals to, R1 is 75 mm, R2 75 plus 25 mm. Is it clear? So here in next what they have given, they have given that temperature of inside temperature 200 degrees Celsius, then the outside temperature is 100 degrees Celsius. T1 they have given is 100 degrees Celsius. T1, T2 they have given is T1 inside temperature they have given is 200 degrees Celsius. This is 200 degrees Celsius. T2 temperature, this is 100 degrees Celsius. Is it not? K, thermal conductivity, K is equals to 0.21 watt per meter Kelvin. So next thing is thickness. Thickness they have given is x equals to, thickness already we have added to this radius. Then substitute this value directly into this value, or length pipe. length of pipe they have not given. The pipe is covered by 25 thickness, but they have not given the length. They instead of giving the length directly, what they have asked, find the amount of heat lost per meter. Per meter means 1 meter. Length of the pipe is 1 meter. So that substitute this value 2 pi into 1 into k value 0.1 into t1 minus t2 100 into t divided by 2.3 log of, so r2 100 divided by 75 into t per minute is the given. Per minute in the sense it is 60 minute 60 seconds. So after solving this, what is the q value? Q value after solving this, q value will becomes 27.55 into 10 raised to 3 joules is equals to 27.55 kilojoules q value. So these kind of problems will appear in your exam. So please prepare these all problems and practice more and more problems. These will help for your exam. This is a 15 marks chapter. So go through this chapter, theory and theoretical part and problematic part. So all the best.